So in the next lesson, we're going to go into this thing called functional groups. And these are the notes that I had you either print out or reference on my sheet. But also something that's really important. If you don't have it out right now, pause the video and come back. But you need to get your reference table out and go to table R. It's called organic functional groups, which is what we're going to be talking about. So pause it now and get it out and then hit resume. But the um, the nice thing about this table is that everything I'm about to teach you, I'm really not going to teach you much. I'm going to, in terms of like, what I'm going to be teaching you is basically how to use the table to understand the concepts, because everything that you need is in here. And so I'm going to kind of be jumping back and forth between them. So I would set up both of your sheets next to one another so you can reference them. We're going to draw on this a lot too, so feel free to do that as well. But basically, a functional group is something added to a hydrocarbon, oxygens, nitrogens, halogens, that no longer makes it a hydrocarbon, but now called something other. And there are many different ones that we're going to go through. This might be a 2 video thing. I'm not sure. But we'll start at the top, and I'm pretty sure this follows this pretty perfectly, so that's good. The first type of other organic compound, something with a functional group, is called a halide or a halocarbon. And if you look here right at the top page, you see class of compound, halide, halocarbon. These things, these functional groups, are what is added to a plain hydrocarbon that makes it something different. You're also going to notice in the third column a general formula. General formula basically is always going to have an R, and it's always going to have something attached to the R. And if you look down at the bottom of the reference table, it tells you that R represents a bonded atoms or group of atoms. Now, what you can add to that is that it's really a group of carbons or carbon chains. And it's not specified how long the carbon chain is, because it could be 1, it could be 2, it could be 3, it could be 4. So R is basically saying, here's a carbon, and how many more carbons are attached, that'll be designated by the name. So back to what we were talking about with the halides or the halocarbons. We've got functional group covered, general formula covered, and the example. And the example is great because you're going to see that as we go through here, so much of the example is going to tell you about what the class of compound is. So you can use these 4 things together to really understand what each thing is, how it looks, where these things are located, how to name it, how the naming is different from than what we've learned. And so let's get into it, right? So for the halides, there are prefixes, and the prefixes are listed right here in the table. You know, if it's an F that's bonded, it's going to have a fluoro name before it. If it's a chlorine, it's going to have a chloro. If it's a bromine, it's going to have a bromo. If it's an iodine, it's going to have an ido. And that just gets put at the prefix at the beginning of the carbon chain that you're going to name. And here's an example, right? So in the example on the reference table, it says 2-chloropropane. So what I know from that, from what we've learned already, is that prop is a 3-carbon chain. And in here, 1, 2, 3 carbons are put together. Now, this is that condensed formula that I told you about that I really don't like, because it's too condensed and it's too jumbled and there's too much information. It's tough to designate what each part is and where things are. But if you notice right here, after the second carbon is a chlorine. And so using all the skills that we've learned, the chloro prefix, well, the propane backbone is the 3 carbons. The chloro prefix told me that there was a chlorine somewhere in this carbon chain, and the 2 tells me where it's located. And you can see 1, 2, chlorine is attached to it. So that's kind of how this works. So the functional group could be multiple things for halides. It could be an F, it could be a Cl, it could be a Br, or it can be an iodine. Now, in the example that we're going to draw, we're going to practice the skills that we learned. So maybe if you didn't understand it too much before, it's really going to help now. But I always, when I go to draw something, I always go to the backbone first because that's the skeleton of everything. So butane is 4 carbons. It ends in ane, so it's an alkane, meaning it's all single bonds. And then it gives me that there's this di-bromo. Now, this is different than the example here because this was chloro. So with bromo being the Br, I have to put a Br in. And then where do I put the Br? Well, I got to put a Br at 1, and I have to put a Br at 2. And that's where that redundant di comes in again. A lot of you are going to ask, or already asking yourself, does it matter where you put the BRs facing? Left, up, down, right? No, it does not make a difference. This one could have been down. This one could have been down with a down, or could have been down and up, or left and up. But it had to be on the first carbon and the second carbon, and then you're good. As normal, we have to add our H's to clear it out. So this carbon has 2 bonds, so it's going to get 2 more H's. This carbon has 3 bonds, so it's going to get 1 more, 2 here, and 3 here. And this drawing is 1, 2, dibromobutane. Using this and using our new skills. So the next set, let's see how I can do this. Probably can't. I'll fold it over. The next set are called the alcohols. And this is what makes something an alcohol. For this, it's not a prefix, so it's a suffix. And this changes, right? Certain things have prefixes, certain things have suffixes, certain things are just straight how to name it. So it's important that we, look at the table to figure out what to do. Now, an alcohol has a functional group of OH, meaning if it has this and only this, we classify it as an alcohol. ROH is basically saying that there's a carbon chain bonded to the OH. Right? I think I can move past that now. But looking at the example given, we have something called propanol. Not propane, not propene, propine, propanol. So I hope you realize that this ending is different than everything we've been doing, because every alcohol has to end in ANOL, anol. That's pretty ugly, but it's folded over. So if we look at it, right, prop means there should be 3 carbons, and in the drawing, there are 3 carbons. The 1 tells me that it's supposed to be on the 1. But it looks like it's on the 3rd one. Remember, when we're naming, we go with the lowest number. And reading this backwards, this would be considered carbon 1. And so the OH group, the alcohol group, is attached to the first one. So we get this 1-propanol name. So the functional group for alcohols is right there. Believe it or not, this is a real question that the Regents exam asks. It asks, which functional group belongs to alcohols? Which functional group belongs to esters? And if you know how to use the table, it's right there for you. So drawing an alcohol, like 2-pentanol, I've identified that it is an alcohol because of the ending. I've identified how long the carbon chain is going to be because I have pent on there. So 1, 2, 3, 4, 5. Now, just like if this had said propene, we would know that there was a double bond. And if it was 2-propene, pentene, we would put that double bond at the second carbon. This is no different than that. There is an alcohol group. Where is that alcohol group located? It's located at the second carbon. So counting left to right, 1, 2, put a little line. I'm going to add this group right here, OH. Fill in my hydrogens to make every carbon have 4 total bonds. And I've just drawn an alcohol. Okay. Ethers are the next one on the list. Now, ethers have this interesting thing. It's an O. Sorry, let me bring this down for you a little bit. Focus. There we go. We get this O in the middle of a carbon chain. So you see the R, there's a carbon chain going that way, or prime, there's a carbon chain going this way. So what I like to refer to this as, it's basically an oxygen bridge. There's an oxygen that bridges 2 sides of a carbon chain together. And looking here, we're going to see that this carbon chain is bonded to this carbon chain by this little bridge of oxygen in the middle. And the naming is really simple, because the naming is just, we name the short chain, then we name the long chain, and then we add the word ether at the end. And so I'm using the exact same example there as I am down here, but it's what it is. Frozen. There we go. But methyl is the shortest chain. Ethyl is the next shortest chain. Ether. So the functional group is an oxygen in the middle. To draw methyl ethyl ether, I'm always starting with the backbone. And as weird as it is, this is the only situation where the backbone is actually not a carbon chain. It's an O. And that's the first thing that I'm going to put on my paper. And from there, I'm going to make my 2 branches. Depending on what the name is, I'm going to decide how my branches go. Now, this is methyl ethyl. So that means that there's a methyl here, and there's an ethyl here. Remember, YL is a branch. So this is the backbone with a branch of 1 and a branch of 2. And that's how you put together an ether and identify an ether. I'll do one more in this video, and we'll start a new video. So the next one is called the aldehydes. Okay, the aldehydes are listed next, and they're designated by this funky looking thing. Basically, this funky looking thing is a carbon with a double bonded oxygen and an H. If we were in class right now, I would say, what do you think the significance of this being an H is? And I would probably wait some more till somebody finally, we deliberated and finally came to the fact of, well, if there's an H, that means the carbon chain must stop. And that's the point. Right? The point is aldehydes are only located at the end of a chain. They can't be in the middle. They have to be at the end because there's an H. It does not continue. So in the example of propanol, we have a 3-carbon chain where this is at the end. And you don't need a number because it's either at the beginning or the end. It's always the first thing there. So the suffix is pronounced anal, and the functional group is CH double bond O. I'm not doing anything crazy with this because it comes right from there. Now, the one thing that you have to know is this. I start with my prop backbone, and this gets confusing. I don't add this to it. So it's not an extra C added. It's just that this last C becomes the functional group needed. And that is propanol.